All right, last week of school. You guys, this is gonna be maybe one of the last couple videos where there's only 2 more things I'm gonna teach you. The others we're not gonna complete the square, although you could do this on your own because it's actually, I like the way that the book describes it. It's not an easy process to do, but some of you could get it really quickly. Also, I'm coming back. So if you're listening to this video, you get to hear this. I am not, though, probably going to come back as your full-time teacher. Miss Awad is still going to be in the room because the district doesn't want me to be back on the payroll. But I might come hang out with Miss Vu or something. I don't know. You might see me around. Yeah, so that's kind of cool. And I'm going to go to graduation, I think, and stuff. Anyway, here's what we're doing. We are going to remember what factoring is, and there are going to be in-betweeny skills. So factoring is our skill right now. You are going to factor out the GCF of polynomials. This is number 1. That one maybe you've done before. It's quite simple, and we're going to have a worksheet on it. Rewrite quadratic equations in vertex form by completing the square. We're going to skip that, but you should know how to do it. And then we're going to complete the square, use method of quadratic. So I think it's going to be this, factoring quadratic trinomials. That's number 2. So factoring is something we've actually already touched on. Factoring is the inverse of distributive property. So here are some distributive property. I'm going to start you off by showing you the distributive property, this one, 4x plus 3. You guys know the distributive property says that you multiply. And the reason I'm showing this to you is so you can see that there is a backward step. So this is now 4x plus 12. But when you are practicing method 1, you are going to start here and go backwards. So the question, when we say we're factoring, the question is, given this polynomial, what did we start with? So when you see that both of these are divisible by 4, you bring the 4 into the front of parentheses and you rewrite it like this. So you'd say, oh, there's a 4. So if I undistributed it with a 4 in the front, this would have to be an x. And then what would the 12 have to be? 4 times what is 12? It's 3. So it's like division. If this is multiplication, factoring is like division. Or going backwards, however you would like to think about it. Okay, so your review is the distributive property, which could be a box. So a reminder that we are in quadratics land where we have 2 different x's and 2 different factors each. So if you do distribute, you need to do it twice. You need to multiply the x with the x and the 2. You need to multiply the 1 with the x and the 2. So a lot of people like to put this in a box. Please try all 4 of these on your own. When you look at number 4, so try all of these. You're supposed to do this, like x plus 1, and then x plus 2, and then you multiply x times x is x squared, x times 2 is 2x, and then you do the 1, x times 1 is x, and then 2 times 1 is 2, and then your answer is x squared plus 3x plus 2. This is how you double distribute. You distribute everything out, you get 4 answers back, and then you combine together to get a quadratic in standard form. So try 2 and 3 on your own. Please check with your neighbors, please. And then when you get to number 4, here is, I will murder you if you put x squared plus 4. The math police will come find you. Sorry, I won't murder you. I love you so much. I'm sorry. Don't get me fired. The math police will come get you, though. You cannot just stick this 2 onto those 2. Because this is not distributive property. This is not like the 2 exponent tells me in words, hey class, what does a squared do? It makes this thing multiply by itself twice. So this is actually saying we have x plus 2 times itself, x plus 2. And oh my gosh, once you write it like this, you will see it looks exactly the same as these, and you need a box method. So when you actually multiply this out, x plus 2 and x plus 2, this is not good enough. This is really bad. This is missing the b term in the middle. It's missing a whole term. Your answer when you multiply should be x squared plus 4x plus 4. So don't forget about those things in the middle. Please ask your neighbors. This is on the final. This is on the final. I'm saying it again. And then when you're finished with this, I'm going to turn the page and we are going to undistribute things. So this is a reminder of how to multiply. Now we're going to divide. We're going to do the inverse. So you're getting started is called LOL the GCF again. If you remember GCF from another math class when you were younger, it's called the greatest common factor. So our worked example is showing you what you are going to have to do. Let's take a look. Let's consider this polynomial. Let's take a look here. Now, this polynomial has already been distributed. Your job is to figure out where it started. So if it had a number in the front and then parentheses, your job is to figure out what went in the front and what goes in here. So we call this the greatest common factor. Your method is to say, hey, between these two terms, what is the greatest common factor that they have in common? The greatest thing that they can both be multiplied by, and the answer is 3. 3 is inside of the 3x, and then 3 is inside of the 15 as a factor because 3 times 5 is 15. So you are asking yourself, what would have had to gone here? 3 times x is 3x, and then 3 times what is 15? Well, 3 times 5, positive 5 is 15. So you can always check your work after this. This is what it looks like here, and they're giving you an opportunity to see that there's a 3 here and a 3 here, so you pull it out to the front. I like to say that if they both have a 3 inside, you bring it out to the front. That's what a lot of math teachers say. The front meaning the front of the parentheses. So for each of these, some of you will have a very simple time doing this. You are going to find something that they all of the terms have in common. So I'm going to start here at number 1. Feel free to pause the video, do this on your own, and then check your answers. If you'd like to follow along with me, great. So here, it's the same thing where we have 2 terms, only 1x. So this is going to be what is in the front and what do we have to multiply by. So what do 4x and 12 both have living inside them as a factor? The answer is 4. And then if you divide the 4, you have to figure out what would come after that. We have an x because 4 times x is 4x. And then don't put 12 here. 4 times what would have given us 12 if we had done distributive property? It's a 3. So this is the answer. If you would like to check your work, you can distributive property. So 4 times x is 4x, 4 times 3 is 12, and you go, ooh, I did do it right, because I just checked my answer and went the other direction. When you go to one like B, you'll see that there's an x squared. So this is actually the first quadratic we've seen so far. And this one, we can still factor out the greatest common factor. So what do both of these have in common? Well, this one doesn't have a number in the front. It just has a 1. So I actually can't factor out a number in this case. I cannot factor out 5 because this one doesn't have a 5. What do they both have in common? Well, instead of a constant term, like a coefficient, they both have an x. So see how this one they didn't both have an x? This one, this term has an x, and this term has an x. So you're actually going to factor out x in the front. And then you're going to say, okay, x times x is x squared, and x times what is negative 5x? It's negative 5. So for factoring the GCF, you have to pay attention both to regular numbers and to variables when you look at all of the terms. Speaking of, C has 3 terms. And if you're looking for a greatest common factor, first we can take a look and see if they have a regular number in common. And then we're going to see if they all have a variable. So right now I notice that this is a trinomial. There is a variable here. It's x squared. So there's 2 of them. There's an x here. And there's no x here. So actually I can't factor out a variable because they don't all have it in common. But what number can I divide each of these by? It's a 3. So challenge yourself. If all 3 of these terms are divisible by 3, what's left over? Well, 3 times x squared would give me x squared, and then 3 times what is -9? That's your division. This is -3, and then we have to have an x, because that's gonna go backwards, and then 3 times what is -3? We have to make sure we leave a -1 there. So that's that. Email me if you still don't understand this question. And then if we get here, so there's easier ways to do this. I'm gonna give you a worksheet on it. I'm sorry, there's not easier ways to do this. There's easier problems to practice on. But I am gonna give you a worksheet so you can practice this. This one is weird because, well, that has an x and that doesn't, so I can't factor out a variable. But what number can I factor out? Because they don't both have the same number either. The answer is that you must factor out the negative sign. So this -1 that's invisible in front of the x, you actually have to factor that in the front, because when you do a factored form, the first leading coefficient cannot be negative, which means that this x can't be -x, that's bad. If you have -x, it's not factored. So now if I bring the negative into the front and I'm left with +x, that's good, and then I have a +7 on the inside. So believe it or not, these two things are the same, and this is the one that is considered factored form. This is factored form. It's linear, it's not quadratic, but it's still factored form. This one is also linear, not quadratic, because there's only one x. We can't factor out an x. But wait a minute, does 2 have a common factor with 11? The answer is no. No GCF, can't factor. 2 and 11 are both prime numbers, so they don't have anything in common. They don't have any factors at all. And then you might like this one. There's a 5 and a 10 and a 5. The 5 in front of the x squared is positive, so we're going to factor out +5 to make sure that that x squared is also positive. And then what goes next to give you your trinomial on the inside? I really do want you guys to try these on your own. Here's the answers. Okay, pausing the video, stopping this one to make a second one. This is going to be a worksheet for you. It's called the GCF. And factoring it out is turning it back into the form before you distributed